we've always focused on user experience here at Mist, right? Be it for user experience on the wireless network. Then with wire assurance that we launched last year, we talked about user experience in the wired network. Now you heard about AI-driven WAN and the user experience on the WAN network. But at the access layer itself, there's another component of user experience that is very important to us and to our customers, and that's all about location services. So I'll take a few minutes to walk you through what we already have and then how we were able to actually meet the need of the hour, where we are seeing location also now become part of that mission critical network. But let's take a step back and see, why has location always been this black box? Why has there always been friction to adopt location services? And the key reason for that is, when you look at what's in the industry today, whether it's proprietary location technologies or whether it's our networking peers themselves, they still have very complex architectures when deploying a location services involved. And with that complexity comes limited scale. Some vendors provide an overlay network with battery beacons, which sounds good when you're doing a lab POC, but when you have to deploy numerous beacons at scale to enable a user engagement solution, it doesn't quite work out. Thirdly, another friction point has always been, whenever you're deploying location, you have to manually calibrate, manually fingerprint, collect signals, make sure that you've fingerprinted your network to get some sort of accurate location. And lastly, a lot of the location technologies have been very, one trick pony, so to say. It's one technology for one use case. And that's what we've seen time and time again as to the reasons why, even though location has been critical to some use cases, especially in verticals such as healthcare and also retail, it has not gone widespread. And that's where, when Mist got founded back in 2014 and we started shipping in 2016, Bob's whole point of view was, we have to make it scalable, we have to make it simple, and it has to be serviceable. It can no longer be a black box that takes, days and days and months to deploy, and then is not usable because some issues are found. And that is where we see this will really help indoor location, go from a nice to have to a must have, because with Mist, you now have that beauty, that benefit of the microservices architecture, which is a key foundation for our cloud platform to deliver enterprise scale. So bring on all the devices you want to locate, be it on Wi-Fi, be it on Bluetooth, and the Mist cloud will deliver those services for you. The fact that we have a true convergence of Wi-Fi and Bluetooth, and on Bluetooth, it's not just another radio that's stuck into the AP, it's the directional antenna array that we purpose built. Still standards based, still supports Edison and iBeacon, but the fact that it has a directional antenna array gives you much higher accuracy for very key use cases, especially now in the world of COVID, when contact tracing is becoming so critical. Thirdly, unsupervised machine learning, right? RF fingerprinting, manual RF fingerprinting has always been the bane of location. You deploy a network, you calibrate it. If you have thousands of locations, imagine sending people out to those thousands of locations to collect data and to fingerprint statically. Gone are those days with Mist. We deliver location services leveraging unsupervised machine learning in the cloud, which completely mitigates the need for any manual calibration. Benefit to the customers: deploy your network as long as they're designed with the best practices in mind, which is where the tools like Ekahau come into play. And then you can start using location services right away. And last but not least, it's not a siloed network. It is a platform that can deliver multiple use cases, leveraging Wi-Fi, leveraging Bluetooth, whether it's asset visibility, whether it's wayfinding, whether it's occupancy analytics, all of the above. So now when COVID hit, was it something new that we suddenly came up with and started delivering to our customers? No. It's the exact same foundation we had already built with microservices, with our directional BLE antenna array, leveraging mobile apps, leveraging asset visibility with badges, leveraging the analytics we already have. And we were able to deliver a proximity tracing solution, again, another innovation driven by our customers, right? The microservices architecture gives us agility, gives us flexibility. Pivoting the same use cases we always deliver to, using that same technology stack, we were now able to deliver for proximity tracing. And that's the beauty of this platform. So let's go into exactly what we are doing for proximity tracing. Again, it's the need of the hour. Every enterprise campus, every higher ed university, in fact, a very large university that we just won, one of the key reasons for them to consider the Mist solution stack was, of course, user experience on the Wi-Fi network and what we were doing on the wired side. But in addition to that, having a scalable, simple platform that they could also enable location services and, more importantly, proximity tracing as part of their business continuity. So when we say location is now becoming mission critical, especially in this global pandemic situation, we are seeing numerous requests come in to say, hey, how can we use your current location technology, but help us solve our current problems? So what are these current problems? The reason we are seeing customers come to us to help us solve these problems is because of the three use cases that we are able to deliver on, specific to the whole contact tracing, or what we call proximity tracing. The first is journey mapping. So leveraging our asset visibility where we can locate with badges, leveraging our location services if a mobile app is required, or even leveraging connected Wi-Fi devices. When campuses are opening up, when enterprise offices are opening up, and if one of the people there self-identifies to be COVID positive, would you shut down your entire store? Would you shut down the entire campus? Would you shut down your entire enterprise office? You don't want to do that because that's a loss in productivity. So what do you do instead? If you had a system which could tell you exactly all the places that self-identified or self-reported COVID positive person went to, you can now have those areas deep cleaned and make sure that those areas are now sort of, as we say, virus free, by knowing exactly where they went to. And if you wanted to isolate those areas, you could only isolate just that area versus the whole building or the whole campus. So user journey mapping becomes critical and is easily delivered by Mist on leveraging any of the three factors, right? Either Bluetooth via badges, or if you're using a mobile app day in, day out, we can use that as a source of data, or just connected Wi-Fi. The second question that comes in then, apart from journey mapping to protect you from, the closures and quarantines, is, hey, who all do we need to notify that was in proximity of this person who has now self-reported to say they're COVID positive? That's where the whole proximity tracing reporting comes into play, where not only are we able to tell you, leveraging the location services we've always had within the Mist platform, as to where this user has been, what all areas they visited. Was it the customer success area, the sales marketing area, the development area, or this particular lab, or this particular conference room, but also be able to tell you, while they were there, who else was there with them. Now, the CDC guidelines keep changing, and I'll show you a demonstration of this, where they say, a person should be in proximity of another person for at least 10 minutes to be potentially exposed. We can build all those complexities into the system and give you a very simple answer to say, hey, this particular person carrying this device, again, be it a Bluetooth badge or a connected Wi-Fi device or a mobile app, was seen in these areas on campus. And while they were there, these were the other people along with them, where they spent at least 10 minutes together. Now, today, that value is 10 minutes. As we learn more about this virus, that value may become 2 minutes, that value may become 15 minutes or more. The system has that flexibility where you can essentially choose, hey, what's the collective dwell between two people, and give me the blast radius of all the people who may have been exposed because they spent time with this, COVID positive person who has self-reported.
So many of the new mobile device operating systems are randomizing MAC addresses now for privacy purposes. How does this solution deal with that?
That's a great question. So the whole user journey mapping and the proximity tracing, first of all, is built on an opt-in technology. So it's using either your connected Wi-Fi device location, but more so, we are seeing a lot of movement towards using Bluetooth badges. So just like we have our current access badges that we all use to scan in to enter a building, you now have from vendors such as HID and Contact.io and any other Bluetooth vendor out there, they have these Bluetooth stick-ons that stick onto your card. And you can now use those to enter the building as well as get continual location. The benefit of that is you don't have to worry about the MAC randomization because it's now a Bluetooth tag that is transmitting a known protocol at a known frequency. Second of all, you have a one-to-one mapping of the badge to a person where you can get better data. And thirdly, you get better accuracy. So MAC randomization is definitely a problem. We know what iOS 14 is going to do, even for connected devices. And that's where we're seeing a lot of the campuses, be it higher ed, be it enterprise, be it retail, especially for employees, associates, moving to leveraging the badge because we're all used to carrying that anyway. And that mitigates a lot of the false positives per se that a Wi-Fi connected device would bring to the table. Plus it's opt-in, you know exactly what you're doing. And given that, again, the Mist APs have that directional antenna array built in, we can give you very granular location, leveraging these badges, whether it's conference rooms or desk areas or how many people in a particular zone, as we call it.
Thanks.
Last but not least, to your point, though, even from a Wi-Fi MAC randomization, even for connected devices, the third use case we are delivering, which is very critical also, is all about even mitigating exposure. This has always been something that the facilities management teams in the organizations have wanted, where they want to know how the space was being utilized. That same use case now is also critical to delivering towards contact tracing. Now within the system, you can go in and set limits. What was previously a 20 people conference room with the social distancing norm now becomes a 5 people conference room. So we can trigger an alert in real time if any particular occupancy of a particular zone is violated. And this trigger could be an email alert going to the security team. This trigger could be a webhook that goes into a facilities platform or the security team's platform. Multiple ways to consume that alert. Again, automation, as you know, is key to our as a building block for us, a foundational one at that. So everything that we do here is actionable, whether it's the youth journey mapping, whether it's the proximity tracing that you can take action on, or whether it's congestion alerting. And I'll actually go into a demonstration of these solutions as well. So this is our user journey mapping proximity tracing view, where this can be made available, given all the privacy issues, made available to only the HR team, the security teams. You can enter the variables as to how far back you want to go in time for a person who's tested COVID positive. You can choose attributes of either Wi-Fi or the BLE badge ID, or even a mobile app-driven device ID. And you can have this query of minimum encounter length. You run the report, the system within seconds tells you exactly all the zones that the device was seen in, which means that's where you need to initiate your cleaning crews. It also tells you how many other devices were in the proximity of this device. You have a view of, again, rewind back in time, see exactly in the last 2 days, the last week, the last 2 weeks where this person was, what zones, and a detailed list of exactly which other device owners you need to notify, given that they were in the same zones as this COVID positive person during that duration for at least 5 minutes. You also get a detailed snapshot in time every 15 minutes of this device's movements, and while they went to various areas or if they were in the same area, what other devices were there. So not only do you have details on who all they spent at least 5 minutes with, even though they may have had multiple encounters with those other devices, but a time series 15-minute snapshot of exactly what other device was there in the same areas that they were there. In addition to that, from an audit perspective, from an insurance perspective, organizations are being asked to prove that they're following social distancing. So we have built this report that we call compliance, where we can look at what zones have stayed in compliance, what zones have not been compliant, and are they or are they not following the social distancing norms. So you have the capacity metric here. We then are doing counting based on how many people we see in that zone, and trying to identify, are there zones that are perpetual offenders? That means despite all the signage, despite all the email notifications sent out, the people visiting those zones are still not following social distancing norms. And this will then lead to other policies that could be instrumented, where you may have a security personnel in those worst affected areas to let people know to take the policy seriously. Now, another key thing that we did, and this is again the end-to-end workflow. You may have seen the announcements we did a week ago around the integration with the ServiceNow contact tracing applications for safe workplaces. So ServiceNow offers the end-to-end case management workflow, all the way from managing PPE devices to managing the cleaning crew tickets to managing the case workflow if a person identifies as being tested COVID positive. And they have various apps as part of their safe workplace platform. So they have built an out-of-the-box integration with Mist, where they're able to ingest the same location data that I was showing you, and they then become that single platform where they are able to, for any customer organization, using our APIs, again, the programmability and automation piece comes in very clearly here. Using our API, they're able to pull all the data into their platform. And now when a person comes in and identifies to their HR team, their security or facilities team, that they have tested COVID positive, they can essentially go in here, enter that person's either MAC address or their corporate issued identity, either through Active Directory, and they're able to get within their system all the data around that person. So where all was the person been, what floors they were on, what zones they were on. In addition to that, also who else was there. And then the ServiceNow integration essentially initiates these cases where they can now trigger notifications to all the people who were affected or may have potentially been exposed to this other person who has self-reported, as well as dispatch client was cleaning the Wi-Fi in those areas where this person was. So very elegant integration with the ServiceNow Safe Workplace apps and the Mist location platform, ingesting the location data be it again Wi-Fi or be it Bluetooth, be it badges, be it mobile apps, and presenting the full end-to-end case management workflow.
COVID-19. And certainly, we can't overstate this. That this actually is such a fundamental, workflow here. ServiceNow is actually in a lot of enterprises. Probably 8 out of 10 customers we're going into now have ServiceNow. For them to be able to consume the Mist data, BLE or Wi-Fi data natively and instantiate workflows from that is amazing, right? And we're super excited. They're not only a customer, they're a huge partner, but now they've actually integrated all the Mist APIs natively. So a lot of our customers who are ServiceNow customers are also pretty happy and deploying some of this. Sorry, Solini.
Sudhir, I have a quick question. Mm-hmm. On the design side, what you just described was great for our current situation and for RTLS in general. What is the recommendation for best practices of how close the APs need to be together to offer that kind of resolution for both BLE and for Wi-Fi?
Awesome. Solini, you want to take that?
Yeah, so I'll take that question. So typically what we have seen and what works out well, again, going back to the question of best practices that was brought up, from a location perspective, the design principles match the high density Wi-Fi principles quite well. So from a high density Wi-Fi perspective, when you're catering to capacity versus coverage, you typically end up deploying APs at anywhere from a 30-foot to a 50-foot grid. That design works well even for location. When it comes down to conference rooms, auditoriums, even in those areas, you are deploying an AP to just provide better Wi-Fi capacity. And that same AP can now also serve the location resolution needed. So nothing special here in terms of if a network is designed for high density Wi-Fi, it plays well with location. The only other caveats would be that you've covered your perimeter, so you have good location even at the edges. And as well as any other areas where you don't need Wi-Fi, but you do need location, that's where you may have some additional 2%, 3%, 5% incremental units. But other than that, from a design guide perspective, high density Wi-Fi design principles work well with location to give you everything we're talking about here.
Just can you clarify what you mean by high density Wi-Fi? That's a huge, high density in the classroom is 30, high density in the auditorium is 5,000. They're both high density.
So
that is correct.
Sorry, Solini. I think Wes and Abhi, you guys do Wi-Fi Ekahau designs every day for customers. Why don't you talk about, sort of how you think through this problem as well? Sorry, Solini, I didn't mean to cut you off.
No problem.
Yeah. So I would say the fundamental question is, for location, do you need to design differently? And usually the answer is maybe. So for Wi-Fi and for BLE, specifically with like a BLE badge, the location is the best when the AP is in the room with the device. And so it really depends on the type of granularity that you're looking for. So if you're looking for, the zone-based, relatively, not 2 meter by 2 meter type zones, AP and in the conference room will get you Wi-Fi and BLE accuracy in that conference room. So it's more use case driven rather than try to blanket statement in AP every 2,500 square feet. Does that help?
Let's say that we're going by COVID guidelines, which is 6-foot spacing. What type of design would give us the fidelity to give us that information, to provide that information?
So you don't actually need to know if somebody was in 6 feet. Like you're not going to get any sort of that's just not going to be. You're not going to accurately or reasonably expect to be able to get that kind of information, but you will be able to say these two people were in the same zone.
Wes, let me just add context. So Jason, that's a good point. Contact tracing by CDC guidelines is 6-foot distance, right? And almost anything, you all know, you guys have been engineers, almost anybody promising you 6-foot proximity tracing it hasn't done Wi-Fi before or BLE. right? So we are calling this proximity tracing with actual specific, with a badge, we have a specific guideline on, 3 to 5 meter accuracy. That is not 6 foot, that is more than 6 foot. And we're not committing to our customers, especially this is health related. We're being very transparent with our customers on, this is the accuracy we're giving you. And so how do you use that data? The way you use that data is when somebody goes and tests COVID positive, you at least know this guy was not, or girl was not in that other building. They were not all over campus. You now know, it narrows your scope down to a floor, an area, and a set of floors or an areas. That's number one. We're calling it this proximity tracing, primarily not to produce an illusion that this is contact tracing by CDC guidelines. That's number one, right? So the accuracy gets better if you're using our mobile app. Accuracy is also very good because of our antenna array using the asset tag or the vBLE badge. And then obviously Wi-Fi accuracy, we feel we do a very good job in the industry, but in general, Wi-Fi accuracy isn't the greatest here. So we're using those 3 realms, being transparent in the accuracy. And so that's why I want to make that distinction, right? So you're designing for proximity tracing, roughly who all were the people in that zone that you may, as advisement notify, not saying, hey, you've been in 6 feet distance of this person, if that makes sense, Jason. Yeah, well, sorry, you were chatting, and then maybe Sunilini, yeah.
Wes, maybe you could just give me, oh, I'm sorry. I was just hoping, Wes, you could give me what requirements you put into Ekahau for primary, secondary, maybe tertiary coverage, at what levels to give you the accuracy that you're after?
So it's what you're trying to accomplish, right? So if in this with the proximity tracing, say I wanted I wanted to know if somebody was in the the big conference room, or somebody was in in the middle of the floor plan, which is the product management area. You would generally want those 2 APs, right? So if we assume we're going to anyway put the design is going to have 2 APs in those areas, so it's not really any, for that type of use case, you're not going to have a different design typically than you would for a regular Wi-Fi design for an office environment. So if we're talking about kind of neg 55, neg 67 cell edges, that you're probably going to want to go more dense than that, right? And typically you would anyway, to in order to handle the amount of capacity that you need. For this office floor plan. So it's I don't know, it's tough to give a you're going to want more dense than neg 65, neg 67 cell boundaries. But how much more dense? I would first design for Wi-Fi, right? And so if you meet your capacity requirements, your coverage requirements are going to be met no matter what, if you're designing for capacity. And then from there you can look at is my client going to be able to hear at least 2 or 3 of these APs, probably better than neg 60 or something like that. That's kind of the mindset that I go through is I do a Wi-Fi design first, and then I go back and see if I need to augment it or add anything specific for a location design.
Yeah, and Wes, just to add to that point, right? So when do we need to augment? So as you said, it comes down to the use case. A lot of the deployments we have done, they're all about getting in-room accuracy. In-room meaning you have a 5 people conference room, you have a 20 people conference room, you're using the badges or you're using Wi-Fi. How do you locate, more accurately, more consistently in those areas? Well, that's where you would need to put a unit there. Now in healthcare, that's pretty common practice when they deploy location to put a unit in every room, or a location, sensor as they call it, because of the proprietary nature in healthcare. But in enterprises, in retail, in higher ed, and you guys are the experts here, you would have seen that you're deploying access points in those areas anyway, just to provide the required capacity. The question is where else, right? Where do you need to increment? So like I said, the edges, the perimeter of the building does need coverage. Is to make sure that you get better accuracy there. If you're doing like a wayfinding project as well, which is where Wes kept saying it goes back to the use case. If you don't care about wayfinding, as you're walking around cubes at the perimeter of the building, then don't deploy. But if you do care about getting that straight line when you're walking down that hallway at the perimeter, you do need perimeter coverage. But within the floor plan itself, apart from perimeter, apart from conference rooms, if you deploy typically, a 30 to 50-foot grid, that should work well. And when I said high density, it typically meant, deploying for capacity. Wes, any other comments there you think we should clarify on from a capacity perspective?
I have a quick question from Twitter. John asked how much historical data is available or compiled for contact and proximity tracing.
Good question.
Great question. So as per the guidelines, what they have suggested strongly is that the proximity tracing, contact tracing data only be maintained for 30 days. So within the Mist platform, we have the ability essentially to purge the data as a rolling 30-day window, so that we are not, so that the customers are using the platform are protected from any legal ramifications of that.
So I have a question, if I may, on your antenna array. So if you're using Ekahau and you're saying that, in hospitals and things, you want to do 1 AP per room, have you designed your array antenna specifically for line of sight? And what is that adding to your planning in order to provide location if you're still doing the planning based on your AP deployment rather than your antenna design? Can you help me to understand?
Sunilini, I can take this one. So I actually have a video pretty much like on this exact topic from Wi-Fi from WLAN Pros, so what we've seen is that the coverage, the BLE coverage that you'll see within Ekahau actually matches very closely with what you'll see from actual data with our antenna array. And so from a design perspective, Ekahau can be used. We do have some tools within the Mist system itself, that you can validate. We have a live view that shows the the live data of that location calculation. It's a very nice view. So that's one. And then second, on the line of sight, there's not a strict line of sight requirement. We can do location through through a wall, but if it's a brick wall, that's obviously going to make a big difference. So the environment does make a difference, and typically our recommendation for for a wayfinding type use case, which is using the antenna array in a transmit fashion, is to have that in the hallways, because that's where people need wayfinding. You don't need wayfinding in a room. Once you get to where you're going, you look up, I'm here. But for things like proximity tracing and asset visibility, that typically happens within a room, and so that more closely matches with the Wi-Fi deployment, where you're typically going to deploy for Wi-Fi in the rooms anyway.
And I might add, Wes, so on the antenna array, there's about 6 to 9 dB of front to back. And what the antenna array really doing is it's tied into our machine learning, right, where we're learning the PLF for every mobile device. So some of the multipath is being compensated for by the machine learning aspect of the system, right? We're learning the PLF for every location and every mobile device, if that makes sense. So when you look at that array, the data it's feeding back, it's giving us some indication of what side of the AP you're on, right? So we don't necessarily have to triangulate, right? In most systems like this, you have to have 3 or 4 APs to figure out where the guy's at. This gives us some information about what side of the AP you're on. So even if it's only one AP that sees you, I kind of know if you're on the left or right side of the AP. If that's your question about multipath and line of sight.
Yeah, that was fantastic. Thanks very much. And I'd appreciate sometime if you could let us have the links to some of that extra material. That'd be fantastic. Thank you so much for that question.
Absolutely. Yeah, thank you so much. So again, the one key thing I want to point out is the simplicity of architecture, right? Everything that you saw here, whether it's badge related, whether it's Wi-Fi connected device related, is all based on just deploying the Mist APs and the cloud. There's no appliances, there's no 10 layers of the onion that you're peeling through to get location. The third use case we also delivered on that you heard me talk about was the hot zone alerting, as we call it, or congestion notifications. So now within the Mist system, you're able to create dashboard where you can assign capacities for every zone, not just draw a zone, but assign capacity per zone. And if any zone goes beyond that capacity, where we're counting capacity based on either badges or connected Wi-Fi devices or mobile apps, we're able to show that view within the portal. And for some of the public venues where, students, guests, visitors coming in won't have access to the Mist portal, we actually have created the ability to generate a QR code. So that QR code could be printed across, and put on around the campus, around the, retail venues where the customers coming in, the shoppers coming in, the visitors coming in, they themselves can see just by scanning the QR code, what is the congestion in various areas. And apparently this is a very common practice in some of the other countries that we're seeing. And this is something that we're bringing as well here as part of the solution. So congestion alerting, congestion notifications, having the ability to create this, what we call a public facing dashboard, either based on occupancy or based on just client density, where they scan a QR code and within the palm of their hand, they can see exactly what the congestion is like. And they can then make their own decision whether I should go to this area or not, is all available as part of this proximity tracing solution. So just a few last slides to wrap up on, and this ties back to the question asked earlier about with Wi-Fi and with the anonymization coming, what's the plan? This is again where Wi-Fi BLE convergence, the directional antenna array, a platform delivering multiple use cases comes to fore, right? Wi-Fi, yes, today we do, as Sudhir said, as good as standards allows, 5 to 10 meters. But where we really are seeing a lot of benefits, a lot of usage is leveraging either a badge, which can stick onto your current access badges. And it's, again, a standard third-party badge will work here, where you get the in-room accuracy for user journey, for proximity tracing, for the congestion alerting aspects. And if you're going the mobile app route, which is also what we're seeing a lot of the higher ed universities do, because they're looking to hand out a safety app to all their students as they come on campus, that mobile app can also be a source of location data, feeding that back into the contact tracing platform, where you can now see exactly where that individual was with their mobile app. And the privacy aspect is it's just tied to a device ID. We don't know who the person who's using it. There is another system that will then map the device ID to the person. So all privacy considerations are maintained, whether it's the badge route or whether it's the mobile app route. But you do have the visibility to see exactly where a person went, so that when or if they report COVID positive, you know exactly what actions to take on what part of the campus. The key differentiation again is the 5 vectors of location for Mist, right? The directional antenna array gives us better accuracy on Bluetooth. Any other vendor out there that is from a networking perspective says they have Bluetooth too. The fact that they don't have the directional antenna array implies they have to add additional sensors, gateways to their network, right? They'll either talk about battery beacons or they'll talk about additional APs. And that's where the Mist differentiation comes in, where we can locate on Wi-Fi, we can locate on Bluetooth. On the Wi-Fi side, by locating passive and connected devices, we can feed the congestion alerting dashboard, which can be made available publicly. On the Bluetooth side, that same platform, that same AP is delivering the mobile apps, is delivering the ability to locate badges and then feed into the proximity tracing dashboard, as well as if you have passive BLE data coming in, that feeds into the congestion alerting dashboard. So 5 vectors of location, 1 AP, 1 platform, machine learning, simplified solution at scale. That's what we're delivering here to the market.